right, so where we left off on Monday is we had graphed this transformed sine function on page 5. An amplitude of 3 and a period of pi, right? And this is what it looked like for one cycle. Okay. So we learned how to graph transform sine functions, right, involving an amplitude and a period. And now we're going to learn about graphing transform sine and cosine functions where there's a phase shift. Okay. So the handout I just gave you, so before we were graphing functions, transform sine and cosine functions of the form a times the sine of dx and y equals a times the cosine of bx. B is greater than 0. It's positive. A can be negative. And now we're going to talk about graphing transform sine and cosine functions of the form a times the sine of bx plus c and a times the cosine of bx plus c. Okay. So this plus c inside the parentheses, right, inside the argument going into the sine and cosine function, creates what's called a phase shift, which is just a horizontal transformation or a horizontal shift of the graph. And back on page 2 of your notes, right, we had an introduction to phase shift, okay, or a horizontal shift in the graph of the sine or cosine function. Okay. In this case, the phase shift was either plus pi over 2 radians or minus pi over 2 radians. Okay. So we're going to learn how to graph transform sine and cosine functions with a phase shift. So top of page 6 of your notes, right, given this form of the transform sine and cosine function, right, we can calculate the amplitude, the period, and the phase shift, right, the amount of the horizontal shift. So calculation of the amplitude and period is the same as before. What's different is we've got to calculate the amount of the horizontal shift. Now, at the top of the page, there are 2 ways of writing this equation. If we factor out a b inside the parentheses here, we have b times x plus c over b if we factor out b. And you can verify that that's correct. That's what the second line is over here. Okay? Is a b has been factored out from inside parentheses, right? So if you distribute the b back inside parentheses here, you have b times x, which is this. And then you have b times c over b. The b's cancel, and you just end up with plus c. Okay? So these 2 equations are equivalent. And so the amplitude, right, is determined from the value of a as before. The period is determined from the value of b as before. And the phase shift, the amount of horizontal shift, is determined by c divided by b. Okay. So we have some examples. Sine, right? Some trig examples of the transform sine function, transform cosine function, and we can determine the amplitude, the period, and the phase shift in the graphs of those functions. Okay? So in the first one, we have y is equal to the sine of 3x minus pi over 4. So we can determine the amplitude, the period, and the phase shift in the graph of this transform sine function. Okay? A, the number in front of the sine function, is equal to 1. B is equal to 3. And C is equal to minus pi over 4, right, in this case. So the amplitude, the graph of this transform sine function is equal to the absolute value of A, which is equal to 1. So there's no vertical stretch and there's no vertical compression. Okay. The period, the length of one cycle, is equal to 2 pi divided by B. B is equal to 3. So the length of one cycle is 2 pi over 3 radians. The phase shift, which is the amount of the shift, horizontal shift, is equal to C over B. And C in this case is minus pi over 4. And B is equal to 3. And now you got to do your favorite activity. You got to do division with fractions, right? And so this is equal to minus pi over 4 divided by 3. And what do we do when we divide with fractions? Keep, switch, flip, right? And so we have minus pi over 4 times 1/3 is equal to minus pi over 12. So the graph of this transform sine function is the graph. Remember, our basic sine function is y equals sine x. Right? That's our basic graph, starting graph. And so the graph of this transform sine function is the graph of sine x. No vertical stretch, no vertical compression, okay? But it's been compressed by a factor of 3, okay? Because the period has gone from 2 pi radians to 2 pi over 3. It's been compressed horizontally by a factor of 3. And the graph has been shifted to the right. This is negative. Remember, it's negative is shifted to the right. Positive is shifted to the left. And it's been shifted to the right, pi over 12 radians. Okay? Any questions on that? Okay, the next example. We have y is equal to minus 2 times the cosine of 2x minus pi over 6. Okay. So our starting graph is y equals cosine x. Yeah, Angus.
I'm sorry, I did have a question about the first one.
Okay.
Is the 3x horizontal stretch or compression?
This 3
Yeah, is it?
creates a horizontal compression. It's like squeezing the spring. Okay. Yeah. So if b is greater than 1, it creates a horizontal compression. And if b is between 0 and 1, horizontal stretch. Okay. All right. So in this example, a is equal to minus 2, b is equal to plus 2, and c is equal to minus pi over 6, right? So you can't say that the horizontal shift is minus pi over 6 radians because it's c divided by b. Okay? So the amplitude the graph of this transform cosine function is equal to the absolute value of A, which is the absolute value minus 2, which is plus 2, okay? The period, remember the period tells you how often the graph of the function repeats itself. The period T is equal to 2 pi over B, and B is equal to 2. So the period is pi radians. So the graph repeats itself every pi radians, right? Which is the same as 180 degrees. And the phase shift, that tells us how much this graph gets shifted to the right. Okay. The phase shift is C over B. C in this case is minus pi over 6. B is equal to 2. And when you do the keep switch flip like we did in this example over here, you end up with minus pi over 12 radians. Okay. So the graph of this transform cosine function is the graph of cosine x stretched vertically by a factor of 2, compressed by a factor of 2. Well, it's stretched vertically by a factor of 2, compressed horizontally, right? This is a horizontal compression by a factor of 2. And then it's shifted to the right, pi over 12 radians. Okay. So there's 3 transformations going on here, okay, in the graph of this transform cosine function. And then lastly,
did you say stretched vertically and compressed horizontally?
so it is, yes. So the amplitude is greater than 1, so it's stretched vertically. The value of B is 2, so it's compressed horizontally. Yeah, so that makes a big difference, right? Right. In both cases, the amplitude and the period, or the amplitude is 2 and B is 2, and so we have a vertical stretching, but a horizontal compressing. Okay. Yeah. And then the phase shift, right, and then the graph lastly gets shifted to the right, pi over 12 radians. All right, and lastly we have y is equal to 5 times the sine of 4x plus pi over 4. So A is equal to 5 in this case, B is equal to 4, and C is equal to pi over 4. So the amplitude is equal to 5. That's the amount of the vertical stretch. The period, how often the graph repeats itself, is equal to 2 pi over B, which is equal to 2 pi over 4, which is equal to pi over 2. Okay. So that's a horizontal compression by a factor of 4. Okay. And then the phase shift, how much the graph is shifted to the left or to the right, is given by C over B. C is pi over 4. B is 4. So pi over 4 divided by 4 is equal to pi over 16. So is the graph, the horizontal shift, is it to the right or to the left?
Left.
Left because it's positive. Okay. So in this case, there's a shift to the left. If it's positive, there's a shift to the left. If it's negative, there's a shift to the right. Okay? Any questions on that? All right, so if you flip over your page, we're going to sketch one cycle of the transform sine function. F of x equals 3 times the sine of 2x minus pi over 4. Now you should be experiencing a little deja vu, because what we graphed on page 5 was f of x equals 3 times the sine of 2x. So the only difference between page 5 and page 7 is the addition of a phase shift. Okay? C is equal to 0 on this page. On this page, C is equal to minus pi over 4. Right? So there's a phase shift. Okay? So we can graph this function. And when you're graphing with phase shift, this is about the only way I know how to really do it. So we have f of x is equal to 3 times the sine of 2x minus pi over 4. And so as before, a is equal to 3, b is equal to 2, and c is equal to minus pi over 4. Okay? So we already know what the amplitude is. Amplitude is 2, or 3, excuse me. Okay? So that goes into blank, right? The first blank. And we know what the period is. That's equal to pi radians. Right? That's all from page 5. Okay. Now the x-intercepts, we don't know exactly what those are yet. Okay. And what the coordinates are for the maximum and the minimum in our cycle, right? We have to calculate those things. So we know what the graph of y equals 3 times the sine of 2x looks like, right? We have that on page 5. What we got to do now is shift that graph either to the left or to the right to get the graph of this function. Okay. So what's our phase shift? C over B. C is minus pi over 4. B is equal to 2. Minus pi over 4 divided by 2 is minus pi over 8. So the graph of this function is the graph of this function from page 5 shifted in what direction? Right, because it's negative, right? And how much do we have to shift it to the right? Pi over 8 radians, right? So we gotta take this graph from page 5 and shift everything to the right pi over 8 radians. The y coordinates, right, we're just going to shift the entire graph to the right, pi over 8 radians. Right? The y coordinates don't change, just the x coordinates change. Okay? So, one way to find the new x coordinates is to create yourself a table. In the first column, go the old x coordinates from the 5 key points: 0, pi over 4, pi over 2, 3 pi over 4, and pi. And then the new x coordinates are the old x coordinates plus pi over 8, right? That's the amount we're shifting it to the right. So the first old x coordinate is 0. We add pi over 8 radians to it. We get pi over 8. Okay? So instead of starting at the origin, it's going to start pi over 8 radians to the right. And then the second key point had an x coordinate pi over 4. You add pi over 8 to it, and you get 3 pi over 8. The third key point, an x coordinate pi over 2. You add pi over 8 to it, and you get 5 pi over 8. Okay? Then when you add pi over 8 to 3 pi over 4, you get 7 pi over 8. Then when you add pi over 8 to pi, you get 9 pi over 8. Well, there was a reason why I went 2 hash marks at a time. When we did this graph on page 5. So at the bottom, page 7. So again, here is what, pi over 4. And then here is pi over 2. And then here is 3 pi over 4. And here's pi. Well, pi over 8 is halfway between 0 and pi over 4. Right? So this is where pi over 8 is. And then here's where 3 pi over 8 is. Halfway between pi over 4 and pi over 2. And here's where 5 pi over 8 is. And here's where 7 pi over 8 is. And here's where 9 pi over 8 is. Okay. So this point at the origin on page 5 is now at pi over 8 on the x-axis. The high point of the graph at x equals pi over 4 on page 5 is now at 3 pi over 8. Everything just gets shifted to the right. And then this x-intercept at pi over 2 is now at 5 pi over 8. And the low point of the graph that was at 3 pi over 4 is now at 7 pi over 8. And lastly, this x-intercept at pi on page 5 is now at 9 pi over 8. And we gotta, right, the y-axis numbers don't change. 1, 2, 3, 4, minus 1, minus 2, minus 3, minus 4. And now you connect the dots. And now we have the graph of this transform sine function. Okay. So this graph is the graph of the sine function on page 5, just shifted to the right pi/8 units. Okay? And all we have to do is calculate the phase shift it to the right. Okay? So now we can write down what the x-intercepts are. The x-intercepts are at pi/8, 5 pi/8, and 9 pi/8. Okay. And where's the maximum located at? 3 pi/8, 3. Right? It's asking for the coordinates. And where's the minimum at?
7, 5, -3.
There you go. And we've successfully graphed that transform sine function. Okay. So the only way that I really know how to graph with phase shift is first do the graph without a phase shift, and then calculate the phase shift and shift it either to the right or to the left, that many units. Okay? Are you with me? So you get practice on the homework. Okay? All right, so let's go ahead and take our quiz.